Hey guys, today we are continuing our work in Unit 5, and we're talking about adding, subtracting, and multiplying radicals. Now, a radical just means a square root, a number inside a square root that we can't really simplify very well. Today we are just talking about actually simplifying and multiplying the radicals. Today's kind of a two-part lesson. Today we're just doing 5-2a, tomorrow we're doing 5-2b. The homework is on the same paper, but we're using 2 days to do it, so keep that in mind. Now, let's talk about simplifying radicals. That's the main thing that we're going to be trying to focus on today is simplifying, simplifying, simplifying. Well, not all radicals are a perfect square. Like if we had the square root of 9, I would know that that's 3. Square root of 16, hey, that's 4. Here are a list of my perfect squares, but unfortunately there's a lot of numbers that don't fall into that. The square root of 80 is one of those numbers. Now, we can use prime numbers and what's known as the cake method, okay, to simplify our square roots, okay? So we're going to cake it. That's what we're going to do today. It's called the cake method. And hopefully after we do it, it'll make sense why we call it that. But here we go. We can simplify the square root of 80. And the way we do this is we're going to take 80. I'm going to write it down over here, and we're going to try to kind of reduce it over and over and over again and keep track of the ones that we use for it. So I'm going to try to think of prime numbers that go into 80 and then just simplify it over and over and over again. So the first one is going to be 2. 80 divided by 2 is 40. 40 divided by 2 is 20. 20 divided by 2 is 10. And 10 divided by 2 is 5. Okay, so we were able to simplify it down. Now the reason this works out is the numbers that are on the outside of my cake are all of the prime factors of of 80. And what we can do is we can now take some of those factors and bring them out. Okay, so we're going to write the numbers that go on the outside and the numbers that stay on the inside. Now, to bring a number out, we have to have 2 of that number. So, for instance, I have 2 2's here. So I can bring to the outside 1 2 because we're square rooting it. Think about these two numbers. 2 times 2 multiplied by itself. So if I square root it, I can bring 1 of it to the outside. So on the outside, we're going to have a 2. We're also going to have another pair of 2's. So we're going to have another 2 on the outside. However, on the inside, we have this 5 left over. Okay? So that 5 is going to be all alone left on the inside. So here's how it kind of works. We're going to write it out. We're going to write on the outside, we're going to write 2 times 2 times on the inside the square root of 5. Then we're going to multiply the stuff that I have out here. If I have more than one thing on the inside, we're going to multiply that together. And we're going to get our final answer. 2 times 2 is 4. And so this is going to be 4 times the square root of 5. Let's talk about why this works a little bit more in detail. Okay? The reason this works is because the square root of 80 equals, the square root of 80 equals the square root of 16 times 5. Now, I don't really expect you to just know that off the top of your head. That's why we use the cake method. But if it's the square root of 16 times 5, look, the square root of 16 is 4. And then we're just left with the 5 left over on the inside. So that's kind of how it works. But long story short, that is my answer. And we're just going to be using the cake method to make it as quick as possible. Okay? All right, let's take a look here at number 2. Don't let that negative on the outside freak you out. That just means whenever we write the stuff that goes on the outside and the stuff that goes on the inside, one of the things on the outside, we already have something on the outside. We have a negative. So we just put in the outside box. Next, we're going to cake it. So I'm going to write my 98 over on the side, and I'm going to go, okay, what's the number that goes into 98? 2 does. So 98 divided by 2, and you can use your calculator to help you with this, but 98 divided by 2 is 49. Then I have to stop and think, are there any prime numbers that go into 49, or is 49 itself prime? Let's see. 2, 3, 5, 7. Oh, hold on. 7 goes into 49. We can divide 7 by 7, and it gets me 7. Oh, wow. So 7, I have a pair of 7s, so we're going to bring a 7 to the outside, and this 2 is going to be stuck on the inside. So let's write this out. A negative 7 on the outside times the square root of 2. And it is simplified. Once again, the reason this works is because it's like 49 times 2 is 98, so we took the square root of 49, but we're leaving the 2 because we can't find the square root of 2. We're just simplifying those radicals. Okay, let's take a look at number 3. Now, number 3 is really interesting because, once again, we start with something on the outside. So on the outside, I have a negative 5 already. But there's something else really interesting about this. We have a negative inside of my square root. Remember what happens when we have a negative inside my square root. It creates an I, an imaginary number. So I'm just going to go ahead and bring that negative out, and we're going to write a negative I out in front. Okay, so I know on the outside, before we do anything else, I have a negative 5, and I'm going to have an imaginary number out there. Okay, next thing, I'm going to write 300 over here, and we're going to simplify this. I'm going to go 300 divided by 2 is 150. 150 divided by 2 is 75. Now we have to think of a number that, a prime number that goes into 75, so I'm going to divide that by 5. 75 divided by 5 is 15. 15 divided by 5 is 3. All of these on the outside now are prime numbers. It's my prime factorization. I don't know if you remember like a factor tree of your stuff. That's kind of the same thing. Okay, so anyways, I can circle these, and I can circle these, because I know if there's pairs of them, they're going to go to the outside. So I'm going to pull out a 2 and a 5. Remember, we need 2 to bring out 1. 2 to bring out 1. And then on the inside, we have left over a 3. Okay, so let's write this out here. Let's write all the stuff we have on the outside, negative 5i times 2 times 2 times 5 times the square root of 3. Okay, negative 5 times 2 is negative 10. Negative 10 times 5 is negative 50. So my final answer is going to be negative 50i, don't forget about that I, times the square root of 3. Really all we're doing, guys, is trying to simplify these as much as possible. It's kind of like simplifying a fraction, okay? That's all we're doing. Okay, number 4. Once again here on number 4, we have something already on the outside, right? On the outside I have a 3, but again, we have a negative on the inside, so we're going to bring out an I to the outside. Okay, so let's simplify 49. Well, 49 divided by 7 is 7. So that reduces, it simplifies perfectly. 7 times 7 is 49, so we're going to bring a 7 to the outside, and then there's not going to be anything on the inside, okay? And so we're just going to have 3i times 7 on the outside, so it's going to be 21i, okay? All right, we're doing great. Let's go ahead and move down and talk about the product property. Pretty much all the product property means is if you multiply 2 square roots together, we multiply what's inside the square roots together as well. So square root of a times the square root of b equals the square root of a times b. Let me show you. Here we have negative 4 square roots of 3 times the square root of 18. Well, we multiply my whole numbers together and my square roots together. So I'm going to go negative 4 times there's not really anything to multiply other than 1, so it's just going to stay negative 4. Okay, but square root of 3 times the square root of 18, well, I have to go 3 times 18, don't I? Okay, and 3 times 18, let me work that out. It's going to be 24, it's going to be 54, right? So we're going to have 3 times 18 is 54, and now we're going to try to simplify 54. So I'm going to go, okay, 54 divided by 2 is going to be 27. 27 divided by 3 is 9. 9 divided by 3 is 3. Sweet. So we multiply together first and then we simplify. All right, so we can pull something to the outside. Let's pull a 3 to the outside. So on the outside, I'm going to have the negative 4 that was already on the outside times 3. And then on the inside, we're going to have two numbers, a 2 and a 3. So on the inside, I'm going to have a 2 times 3. Okay, negative 4 times 3 is negative 12. And then 2 times 3 is 6. So my answer is going to be negative 12 times the square root of 6. So let me make sure that's correct. I think I might have messed up somewhere. Let's see. Nope, looks good to me. Okay. So let's move on to number 6. Number 6, we have 2 square roots of 12 times 2 square roots of negative 3. Once again, we're going to multiply our stuff together. 2 times 2 is 4. Square root of 12 times negative 3 is going to be the square root of negative 36. Okay, negative 36 is a perfect square. It equals 6, right? But remember, we have that dang negative right there, which means we're also going to have an I going to the outside. And so we're going to have 4i times 6. 6 times 4 is 24, so we're going to have 24i. Okay, our last problem here, number 7. So number 7, we're going to do the square root of 3 times 5, and the square root of 3 times the square root of 3. We're going to distribute. Okay, the square root of 3 times 5 is 5 square roots of 3. Plus, the square roots of 3 times square root of 3 is the square root of 9. Well, we know the square root of 9 is 3, so it's going to be 5 square roots of 3 plus 3. But make sure, remember, we want our whole numbers first, and then my radical numbers or imaginary numbers. So we're going to write it in the other way. We're going to go 3 plus 5 times the square root of 3. And that's going to be my answer. All right, guys. I hope this all makes sense to you. As we continue on, make sure that you're always asking questions. And I hope you have a great rest of your day.